Pan, you are the Deputy Principal Investigator of a suite of instruments on Curiosity called SAM, but that stands for something else, and that is?
Well, we could say it's Samantha. We have determined she's a girl, but actually it means Sample Analysis at Mars.
And what does this suite of instruments, what is this supposed to do?
So Sample Analysis at Mars does a lot of things, but basically it's a chemist. And the suite measures gases only. But it has the capability to take solid samples, ingest them through a little inlet funnel, put them in a cup, move that cup over to an oven, and heat that stuff up. And then it becomes a gas. And when stuff becomes a gas, we can analyze it and determine what its chemical content is. We can learn a lot about Mars by looking at its materials. We can learn what the chemical potential is at the surface. And by that I mean, what kind of chemistry can happen? The reason why we want to ask that question is because that potential will tell us whether or not Mars could ever have supported life. And in fact, it tells us a lot about what sorts of resources might be available should humans decide to go to Mars. It's a long trip, and if we have to take all the fuel we need to get there, plus all the fuel we need to get back, it's going to be very difficult. So once we're able to assess the inventory of usable resources on the Martian surface, it has huge implications for human travel. But beyond that, we have to understand the physical environment of Mars, because Mars receives a lot more radiation coming in than does the Earth, because it lost its protective magnetosphere. So the kinds of radiation that attacks the Martian surface, while it wouldn't harm us on Earth, could be devastating to humans on Mars. So we have to learn what materials are there to help us protect ourselves once we go.
Mike, tell me a little bit about what you expect to learn from Curiosity if it lands and everything is successful.
Well, Blair, I think this is one of the most exciting missions we've had to Mars since Viking back in '76. In fact, it's the very first one we could say is related to astrobiology, the search for life on Mars. In this case, they're not really searching for life itself. They're looking for evidence that maybe habitable conditions existed on the planet when it was young. For those of us who are interested in the atmosphere of Mars and trace gases that could be the product of life, we're very excited by the tunable laser spectrometer, which is on board one of the instruments, the SAM instrument, on the MSL lander.
Now, you didn't develop SAM, but you're a scientist basically chomping at the bit, if you will, to get the data back from SAM.
Well, the thing that defines scientists is curiosity. And not just curiosity, the lander, but I mean the fact that we always want to know why. How do these things happen? What's going on? Well, what does that mean? And so on. And so for me, the Curiosity lander is aptly named because we want to know. Did Mars ever have life present? Was it habitable in its early history? And SAM and MSL, some of the other instruments as well, will tell us some of the answers we need to know.
So what kind of things do you think SAM will tell you about Mars, both the atmosphere and or the geology, if you will?
Well, let's start with the atmosphere. My team identified release of methane on Mars in 2003 and later in 2005. And we argued that this, in fact, was methane that was released recently, that it could not be ancient. That is to say that somehow this is being produced and being released on Mars. On that instrument on SAM, called the tunable laser spectrometer, it will have the capability to measure methane as a function of time. And so if they see just a low level initially, maybe if there's a release somewhere else on the planet, they'll see a burst, an increase, and then a slow decay as that methane gets diffused, and maybe a little later another burst, and then there's another slow decay. So by looking at these signatures, methane release as a function of time, they can identify how far away the source was, whether it was northern hemisphere or southern hemisphere, and so on, and really give us a good picture of the release versus time.
Why is methane so important to find on Mars, or why is that something you're interested in?
The reason is it shouldn't be there unless it's being produced and released now, because the atmosphere of Mars is primarily carbon dioxide. which can oxidize the methane and convert it to other forms, initially methanol and formaldehyde, and finally CO and CO2 again. So when you see this methane on Mars, then we'll know that this methane was released very recently. And if we see a burst of methane with a decay, then we can see the burst and then maybe a long decay. We can measure how rapidly it was released and how rapidly it's destroyed or diffused as it moves through the atmosphere. And by the way, even a negative measurement is important, because if we don't see methane, that would then say, well, maybe what my team saw a few years ago was one-off. That is, it happened once and isn't going to happen again for a long time. So we think the negative would also be very important.
We don't really know the complete inventory of materials on Mars. Every time we've gone to Mars, whether it's in an orbital mission or on the surface, we learn something about the materials. But Mars Science Laboratory is the first mission that is sending a complete mineral identification kit. It's a powder X-ray diffractometer called ChemIn. And what that does is it uses an X-ray beam to actually diffract against the layers that make up atoms of specific minerals, and it tells you precisely what the minerals are. That's going to be amazing. And then you couple that together with our instrument suite, the SAM suite, which can look at the chemistry in those minerals, because when you have a mineral, it can have a sort of type of chemistry, a desired chemistry. We call that stoichiometry.
Stoichiometry?
Stoichiometry. You take this type of atom here and you put this type of atom there and you make this kind of structure, and that's the mineral. But nature likes to confound us a little bit and can substitute sometimes one atom for another. So knowing which atoms have substituted for others is very important. It could tell us something about the thermal history or the pressure. So as we look at the precise mineral identification from ChemIn, and then we look at its chemistry from SAM, we learn a lot about that mineral's history. And because we can directly inhale atmosphere, we can sniff the present air and compare it with trapped samples of ancient atmosphere and learn something about the evolution of the atmosphere. And that's kind of cool.
Will we learn enough to actually begin to think seriously about a human mission to Mars?
We will, of course. And in particular, if you really want to think of long human presence on Mars, that is more than just going there for a week or two or a month and then returning, then you have to develop knowledge of where the assets and resources are on the planet that humans could actually use. And so we think that there is a great deal of water ice below the surface of Mars. And so this is a very important question, is to identify where that water ice is and where it might be accessible. And one way of doing that is to look for active release of water vapor from these putative vents. If you find those and you can identify some that repeat annually on Mars, then you can say, okay, it looks like there's a subsurface aquifer here, and with the proper drilling equipment and so forth, purification and so on, one could imagine extracting significant water over.
Setting up shop.
Yeah, exactly right. And then beyond that, we know that there's abundant carbon dioxide on Mars. You can make things from organic chemicals if you know where they are. So you can have the basic materials in order to create compounds that algae and other living creatures can use to create foodstuffs and proteins that humans can eventually consume. This is a challenging long-term enterprise. It's not something you do overnight.
We're going to learn a lot, but we could come away with more questions than answers at the end of it. But be that as it may, Mars Science Laboratory is absolutely the most capable laboratory that's ever been to another planet. And not only the array of instruments and how they work together, but the enabling technology that supports it will allow us to make measurements all through the year, through every season, at day and at nighttime. We couldn't do that with solar panels. But now that we have our MMRTG, or multi-mission radioisotope thermoelectric generator, which charges a big battery, we don't depend upon the sun and the efficiency of the sun angle to charge a panel. So this is important because asking questions at different times of day and night is key to being able to answer those questions. They're complex questions, and they require more than one attempt, and they require careful fitting of the data together, because it is a puzzle, a very complicated puzzle. And it could turn out to be even more complicated than we might have imagined. But by repeatedly asking questions, and asking a variety of questions, and getting independent and corroborative answers from all the pieces of our very sophisticated payload, I think we have a good shot at making some very significant progress to understanding Mars.